Welcome to this joint DevOps session between TNS DevOps team led by Romain and Lionel and us, the Cloud team here at Agaetis, represented by Jean-Loïc and myself, Florian. So we will present you the DevOps Audit and Cloud DevOps. So in this presentation today, we'll cover two complementary perspectives, the DevOps auditing, so presented by Romain and Lionel, and then the DevOps in the cloud that Jean-Loïc and I will walk you through. So before diving in fact, we'll just take a quick step back and recap the core DevOps pillar and practices, just to make sure that everybody is aligned and that there is no mistake or confusion about what DevOps mean.
Before we dive into the cutting-edge practice, let's establish a foundation. When people think about DevOps, they often think about tools, Docker, Kubernetes, GitLab, Terraform. But here is a critical point. DevOps is not just tools. It's fundamentally a culture and a strategy. Let me break this down into the four pillars with concrete examples. First, we have culture. This ensures your team in a shared purpose. Break down silos between dev and ops team, and learning from failure is valued over blame. Example, when your application goes down, instead of developers blaming operation and operation blaming developers, DevOps culture means shared ownership. The team that writes the code runs it in production and use blameless postmortem to learn, not point fingers. Second, automation. This makes your progress sustainable. Eliminate manual, repetitive tasks through infrastructure as code, CI/CD pipelines, and automated testing. Make deployments consistent, fast, and reliable. Example, manual server provisioning that took days or a week become a 10 minutes automated deployment with infrastructure as code. That manual process transforms into consistent, repeatable automation. Third, measurement. This makes improvement possible. Instrument everything. Track deployment frequency, lead time, change failure rate, and mean time to recovery. Data-driven decisions replace guesswork. You can't optimize what you don't measure. Example, a company can go from quarterly deployments with 2-hour downtime to multiple daily deployments with 0 downtime, all by measuring their process, identifying bottlenecks, and systematically improving. Finally, sharing. This turns individuals into collaborative systems. Build knowledge sharing systems through documentation, runbook, chat-driven operation, and transparent incident response. Scale expertise across the organization. Example, chat-driven operation in shared channels mean when a junior engineer sees a senior engineer debug production issue in real time, learning happens organically. Shared runbook scale knowledge beyond individuals. These four pillars work together. Tools enable them, but culture drives them. Keep this framework in mind as we explore the modern DevOps landscape.
And yes, when we speak about modern DevOps landscape, there is fundamental practice that we have. So first, as Jean-Loïc already said, automation at the core of everything, CI/CD, GitLab CI, GitHub Action, even Jenkins if need be, and infrastructure as code like Terraform, Pulumi, Crossplane, those kind of tools. Monitoring and fast feedback loop also allow teams to deliver change frequently but more safely. So the goal is simple, really reduce manual steps, shorten feedback, and catch issue and drift easy and as early as possible. Secondly, the DevOps nowadays needs left shift mindset. What we try to do is to have security, quality, and testing at the start of the cycle. So not at the end of the daily process, but really integrating all along the path from code to production as early and as automatically as we can. And finally, as we already said, the build it, you run it model. The idea is to make people accountable for what they put into production. Ownerships create better software, more reliable systems, stronger collaboration, and also it's at the core of the DevOps philosophy, and that's what really DevOps is about.
Now, let's look at the DevOps landscape from a roles perspective. As you can see from this graph, the demand for DevOps professionals has been growing, and we are now seeing this trend continue. What's interesting there is not just the volume of roles, but the diversity. DevOps is no longer a single job title. It's evolved into specialized roles. Site reliability engineers, platform engineers, DevSecOps engineers, cloud architects, FinOps, AIOps, and more. Each brings specific expertise to the table, but all share that core DevOps mindset we just discussed. This growth reflects a broader shift. organizations are realizing that DevOps isn't a one-person job or a single team. It's a transformation that requires investments in people, skills, and organizational structure.
So now we will dive into what we can do with an audit in DevOps. So basically, the question you need to know is, or a customer is your DevOps workflow truly healthy? So that's exactly why we need this question, is because in our technologies flow, we have a high complexity introduced with microservices, containers, and multi-cloud environments that help with automation, but can also create some efficiency issue, security gaps, and so on. And so what we need is to have something to say we have something to truly help discover and see the misconfiguration, hidden risk, and basically all securities that could produce a lot of issues. So one example is you have a customer that is currently running 10 projects, and you have suddenly an issue. Do you know exactly how many times you need for remediation? That's exactly the question customer will ask, and in mean it's 72 hours, so which means 3 full days of fix. That would be, a loss in benefits, or worse, it would be real dollars that will go away. So that's why we need to analyze the pipelines and also help discover. So we will look at the audit now. So what we will cover today is basically how we made an audit in modern DevOps infrastructure. So first, we'll dive into the arguments that motivate a DevOps audit, the way we perform them at TNS, and finally, it brings what it brings for added value at the end for the customer. So first, the DevOps audit is think it as a health check of your infrastructure and your processes. So it will help with a structured evaluation of the processes, tools, and practices. So basically all the workflow, all the tools, so Jenkins pipelines, or the different Git project, how they are configured, how people are working with them, and what makes them efficient or not. After, we'll ensure that the speed of every pipelines are optimal, and also that the security is enforced. And finally, we will also look at everything we could improve. So basically, we will analyze things by a lot of interviews and so on. We'll explain after the methodology, but basically it will bring a more concrete view of your current infrastructure and how it works. Why we need DevOps audit now? So as I said, the modern environments are complex, and basically with microservices, containers, and multi-cloud setups, it will be very difficult to have a full overview of the system if you are working with it every day. So you need an external view that will help you have a better understanding, that will also reduce the risk of the inefficiencies and the security gaps. And that's why audits kick in. If you have a good audit with a lot of parameters, then your customer will have a full view of what the improvements will bring to him. So it will help reduce cost, it will help improve efficiency, help your users be more confident with their code and deliver on time and with a better quality. So if audits are so important, what's in it for the customer and why should it care? So basically, the customer, it will expose the hidden risk and inefficiencies that are inherent to their workflow. So basically, most organizations don't see their blind spot until you show them. So that's exactly what Florian said before. If you don't measure it, you cannot see it. And that's exactly where audits are powerful. It will help be more efficient in the way you plan the recommendation for the customer, help to have a long-term support for them with some return of investment that is clearly visible from the beginning of the project. That's exactly the audit is here to help customers have a good vision on their infrastructure and processes. We are working with proven data, so not only best practices, but also data coming from them to help them clearly have a view on the KPIs that could be directly linked to the action we will make.
Now that we know why it matters, let's talk about how we actually do the audits for the different customers. So actually an audit is not finger pointing. It's rather giving a company basically visibility for the short, middle, and long term, and define together with the customer what all should be the goals, the immediate goals, what are the important actions to be performed. And to do that, it will drive, basically, with this information, it will drive how the audit will be performed and which questions should the audit answer. For example, how do the people, my teams work together, and so on. So to answer all these questions, there is a dedicated flow we are following. So, of course, we are heavily relying on collecting the data from the customer servers, driving also interviews with the teams that are involved in the process that DevOps will impact. And finally, looking how they collaborate together. Sometimes they are using the right tools, but not the right way. And sometimes they are trying their best to work together, but without the modern and useful tools, the one that they can achieve the best efficiency, the best security, and so on. And finally, like with all this information, look at, where are you compared to the state of the art in terms of efficiency, in terms of security, in terms of visibility, that the actions, the daily task that the team perform, you need to measure it to know how efficient you are and how maintainable your workflow and your processes are. So then we can jump to the tools we use. So basically, this audit is divided into 3 layers. A first layer, before even analyzing in deep details, is the questionnaire, to have a better understanding, basically, what are the current pain points of the team, what are the already visible improvements they have, and we basically leverage on this information to go even further in the analysis. And let's see more in details about the problem the customer told us. What is the root cause, and how do we solve each and every problem? How do we improve each and every aspect that they are unsatisfied about? So we also rely on scripts to perform, to have a rating on different processes, how it is respected and how it is compared to the state of the art. And finally, we, as we said earlier, audit brings visibility. So we also give maturity matrix to give basically all within one quick look. We can see, what are the axes of improvement, where the priority should be set. So after all this analysis, of course, we have to structure it so it is understandable for the technical and the non-technical counterparts on the customer side. And that's why we need a clear, clean, and structured report. So the report makes basically all the learnings, all the analysis, and the conclusions visible and tangible. It is structured in 3 levels. So the first level is usually for non-technical counterparts in order to really understand what was performed through the audit, what are the outcomes, like the conclusions, and finally, what are the main improvement points, what are the main priorities the customer should care, the customer should work on. And this is based basically on the 2 following steps or parts of the report. The strength, so what is the customer doing great? What is the customer doing wrong? And for each missing pieces, for each gaps, how to fill that gap, how to resolve the situation on sometimes very critical aspects, sometimes security, sometimes efficiency. It all depends on also the customer business goals. Is it interested way more into the automation and the efficiency, or is it more interested in the security and the reliability, stability? And and once we have this all gaps and all, then we give clear actions to be taken and the expected return on investment they can expect on each defined actions. After with all this information, then we are able to create some nice dashboards, visualize the data so it's more understandable for the customer. Here, this is where I will speak about metrics. So this is all I was saying before. Each action is related to a return on investment. So that any effort that has to be invested can be compared to what it will bring to the team in terms of cost reduction, in terms of speed, or in terms of reusability, so less of a burden on daily task. And to really compare and to evaluate each and every recommendation, we use key performance index, so KPIs. And in our case, it can be deployment rate, how fast you recover from an issue, etc. And then using that, we can give top 3 recommendations, what are the risks in your processes, and again have prioritized actions and scoring system to achieve the desired maturity and really resolve the critical gaps that were found. A report alone is nice, but it doesn't change anything. So how we turn each and every KPI, each and every gaps into concrete actions to be taken. Basically, we have a priority has to be given so that the customer can really focus on where he will gain the most out of improvements. That's why there is quick wins. As I said, the minimal efforts to achieve the biggest gains, or basically the first actions we will push or we will propose to the customer. Then, of course, comes the all the technical parts, aspects that are maybe more of a work, but on very big processes and very big concepts of DevOps, such as automating everything, bringing infrastructure as code, dashboards for the observability, and so on. And then, of course, there is the non-technical aspect, which is the organization, how they are using their tools, how are the teams collaborating together, are they following the same processes? This is the last and also this one of the focus points on of the audit and the actions that are suggested to the customer. Finally, basically, this audit is definitely an entry point with the customers to give them really the keys to improve the situation for them and to accompany them, so to really support them on the long term, for example, into improving their key performance index over time, and also like driving their transformation that was suggested by the audit, and also training the teams to ramp up with these new processes, with these new tools over time. So making sure the adoption is done correctly and with confidence for the teams, that whatever actions that was taken is producing the expected results, and if not, see where eventually a problem has appeared, and work on that on the long term with the customer. Okay, in short, what is important?
To summarize, audit gives some visibility and confidence to the customer to continue driving its transformation toward modern systems. It also gives a data-driven decision for helping him in his processes to be sure it will be on the good path to have a good scale on his businesses. And also it will improve, and so he implement the continuous improvement as a goal for him to help him continue his business sustainably. So that's exactly what audit gives him. So it gives us the confidence also for the support. And for him, it will give some key KPIs in the future to be sure we are on the good path together.
Okay, and now we've seen basically audits. So the audit approach to really focus on the DevOps engineer part, where the key focus point is really how the teams are collaborating, how efficient are the team working, and making sure the daily tasks are done with efficiency. But now let's jump a little bit on a different aspect of the whole, let's say, DevOps world, more towards the cloud aspect that Jean-Loïc and Florian will go over. So the mic is on your side, guys.
Indeed. So yeah, the cloud is an incredible playground. In fact, it gives you speed, scalability, a lot of possibilities and capability, almost unlimited. But it's also a huge sandbox, and in a sandbox you can build great things or very messy ones. And trust us, we've seen both, and especially the later one when it comes to companies. So without proper governance, tooling, and processes, it's very easy to create insecure, insufficient, over-engineering system. And that's where the DevOps mindset becomes even more critical. So everything we've learned from years of on-premise experience, like automation, standardization, ownership, feedback loops, every DevOps principles that we've learned and loves to see still apply to the cloud. And in fact, it matters even more in the cloud. So the real question is not how fast can we move in the cloud, but how do we apply DevOps principle correctly in this environment? How do we make sure we're moving to the right direction while fully leveraging cloud advantages? And that's what we're going to showcase in the next slides. So first, we can talk about the cloud native and automation because it's really where DevOps come to life in the cloud, honestly. It starts with infrastructure and governance as code. Infrastructure as code means we no longer click through Cloud Console or run manual command to create resources, but instead we describe everything as code. Server, database, network, identity, security, governance, everything. All of that can live in version control files that can be reviewed, test, audit, same as your application code. So think of it just like a kitchen recipe. In fact, if you follow the same recipe, you always get the same results. That's what we try to do with the cloud, to have something that is reproducible, predictable environment. So we always can use tools like Terraform, Pulumi, or Cloudplane to help make sure this is possible. On top of that, we also have the governance and policy as code. So security, compliance rules are no longer documents. They can be automated checks. If someone tries to deploy something that doesn't meet security, the platform simply blocks it. No manual review, no debate. It's enforced by design. But defining infrastructure as code is only half the story. We also need a reliable way to apply and maintain this deliverable state. And that's where GitOps comes in. With GitOps, Git becomes a single source of truth. We describe the desired state of one infrastructure and application directly in Git, and the system continually enforces it. So you can think of tools like Argo CD or Flux to monitor Git and automatically synchronize what's actual environment would be. If something drifts, it's corrected automatically. This gives you something extremely powerful, a full audit trail. Every change is tracked. You know who made it, when, and why. If something goes wrong, it's easy to understand what happened, and so easy to go back in a good state in a matter of minutes. For infrastructure, security, compliance, and audit team, this is really a game changer. But why are we doing all this in the cloud? This brings us really to the cloud native architecture, the cloud native mindset of the cloud. Cloud native means container, microservice orchestration, like Kubernetes, serverless or fast, even event-driven system. Every architecture are designed for speed, flexibility, and resilience. Systems are ephemeral, and we try not to fix server, but we directly replace them. We don't scale manually. We have platforms that do it for us. And because everything is automated and defined as code, the speed doesn't come at the cost of control. So all in all, infrastructure as code define what we want. GitOps ensure it stays the way it is automatically. And cloud native architecture gives us the speed and flexibility to innovate safely. Together, this practice forms the foundation of modern DevOps in the cloud. Without them, everything else we'll talk about, security, FinOps, observability, everything will come after that, becomes much harder. You can't secure what is undefined, you can't observe what is inconsistent, and you can't move fast if every change is manual and needs complex reviews, explanation, and understanding.
Yeah. Let's talk now about one of the most critical evolutions in DevOps, maybe, security and compliance. Security is no longer an afterthought. It's deeply integrated into every stage of the development lifecycle. And this is not just about protecting your organization, it's about building trust with your customers and meeting increasingly strict regulatory requirements, GDPR, Sierra, things like that. So first, we start with shift left. Florian talked about in the beginning of the talk. We are integrating security from day one. Security isn't something you bolt on at the end. It's automated directly into your CI/CD pipeline. What does this look like in practice? The word is static application security testing. It's run on every commit. Container image scanning happens before any image is pushed to a registry. Infrastructure as code is validated against security policy before deployment. Vulnerabilities are caught early when they're cheapest and easiest to fix. This means developer gets immediate feedback on security issue as they code, not weeks later when it's more expensive to remediate. We are seeing organizations reduce their security debt just by implementing proper shift-left practices. Second, we got supply chain security, and this has become critical. We are in an era where you can't trust anything by default. The reality is that modern applications are composed of maybe 80 open source dependencies. Every dependency, every container image, every artifact needs verification. We are seeing widespread adoption of software bills of material, SBOMs, which give you a complete inventory of components in your software. Combined with signed container image using technology like Sigstore and Cosine, you can cryptographically verify that what you're deploying is exactly what was built in your trusted CI environment. Zero trust verification at every stage of your supply chain is no table stakes. If you're not doing this, you're exposed to supply chain attack. They could compromise deeply your entire infrastructure. Third, and we talked about it in the previous slide, compliance as code. Manual compliance checks are gone. We are automating policy enforcement using tools like Open Policy Agent, Cloud Custodian, and Cloud Native Policy Engines. Compliance isn't an audit anymore, where someone with a spreadsheet checks boxes. It's continuous monitoring and automated enforcement. Your infrastructure code and your compliance policies live in the same repository in Git, a version and tested together. Want to enforce on AWS that all your S3 buckets must be encrypted? That's a policy. Want to ensure all databases are deployed with a tagging policy? That's a policy. These policies are tested, peer reviewed, and automatically enforced. Compliance becomes part of your continuous delivery pipeline, not a separate process like it was before. Finally, visibility and protection. Real-time security posture monitoring through CM systems and Cloud Native Application Protection Platform, Snap, give us unprecedented visibility. We are talking about real-time threat detection, automated incident response, and continuous security posture assessment. This system analyzes millions of events per second, creating data from logs, network traffic, and system behavior to detect threats that would be impossible for human to spot. We can detect, respond, and remediate threats in minutes instead of day or week or never. The key message is security and compliance are not friction anymore. When properly automated and integrated, they actually accelerate delivery while reducing risk. The organization doing this well are deploying more frequently and more securely than ever before. Security and speed are no longer trade-off, they are complementary. Final topic for this part brings together two critical disciplines, observability on the cloud and FinOps. These are no longer separate concerns. They are deeply interconnected, and we'll see how. Let's start with observability. Open telemetry, or OTel, has emerged as a vendor-neutral, unified standard for collecting metrics, logs, and traces. Instead of being locked into proprietary monitoring solution with different SDKs and different data formats for every vendor, organization can now instrument their application once, using OTel and send telemetry data anywhere. OTel give you flexibility, reduce vendor lock-in, and provide consistent observability across your entire stack, whether it's on-premise, multi-cloud, hybrid. This matters because the average enterprise is using maybe 2 or more different cloud providers and multiple SaaS platforms. Without a unified observability standard, you're managing many different monitoring tools with no consistent view. OTel solve this, and maybe try to solve this. You instrument once and your telemetry becomes portable. You can switch observability backends without rewriting your instrumentation code. And that's the good part. It gets really interesting. It's observability data doesn't just tell you if your system is healthy. It now drives FinOps decisions. When you can correlate performance metrics with cost data, you can make intelligent and data-driven trade-off. Let me give you maybe a concrete example. A microservice is consuming significant compute resources. Is that microservice worth its compute cost? By correlating trace data with business metrics and cost data, you can answer that question. Maybe that service process payment, high value, justifies the cost. Or maybe it's generating reports that no one reads. It's no a candidate for optimization or elimination. Should we scale down this restaurant during off-peak hours? Observability data show you exactly when your traffic patterns drop, allowing you maybe to implement auto-scaling that save money without affecting user experience. This kind of optimization isn't guesswork, it's data-driven decision-making. Observability provides the insights that make financial optimization possible. And that brings us to FinOps as a discipline. This isn't just about cutting costs. It's about financial health and accountability in cloud environments. We are talking about real-time tracking of cloud spend with visibility down to individual resource and tags. Automated optimization recommendation powered by machine learning that identify idle resource, right-sizing opportunities, and maybe reserved instance candidates. Forecasting based on usage pattern and business metrics, so you can predict your cloud spend with accuracy and avoid surprise on your monthly bill, like it's the case with many customers. And critically, granular cost allocation to teams and projects with cost allocation tagging, things like that. When engineering teams can see the actual cost of their service in real time, behavior changes. Teams become accountable for the spend. FinOps brings the same rigor to cloud spending that DevOps brought to software delivery, measurement, automation, and continuous improvement. Operational excellence includes financial excellence. Observability and FinOps work together to ensure you're not just building a reliable performance system, you're building sustainable, cost-effective ones. The cloud gives us incredible agility and scale, like said Florian, but without observability and FinOps, it's easy to overspend.
So indeed, as we've seen today, DevOps practice should be true and applied at every step of the journey. We'll talk about that a lot, but really, that's the important message. The cloud is really not a shortcut. It's the perfect environment to apply and strengthen, scale the right tooling and mindset across the entire DevOps lifecycle. Security, governance, compliance are really not optional at all. They must be core priority when designing both architectures and application, not something added at the end, again. Monitoring and observability are equally critical. Long metric and trace give you the data you need to understand what's really happening in your system. And without data, as we can see, you can't measure progress, identify failure, or improve reliability. And finally, keep in mind that the cloud is a really powerful accelerator. It can greatly improve processes and applications, but it's not magic. Anything done badly will simply fail faster and at a larger scale. Higher cost, poor performance, serious security risk can happen. So really keep that in mind. Use correctly, the cloud is a force multiplier, but use carelessly, it amplifies every mistake.
So let's talk about the incoming challenge and ambition for the incoming year. We can start with that maybe the most exciting and challenging frontier, AI in DevOps. Artificial intelligence is everywhere, like you know, in our development workflows. Developers use AI assistants to generate code, write tests, and create infrastructure as code for the cloud too. But we need guardrails. AI-generated code must go through validation pipelines, respect sensitive data boundaries, and meet the same quality standards as human writing code. Automated testing and human oversight are essential, and it's important. Then there is high security and compliance. Deploying AI models in production means you're subject to regulations. These are legal requirements. You must protect models from attacks, ensure data privacy, and maintain audit trails. AI governance is now part of the DevOps responsibility, with many other things to deal with. On the operational side, AIOps is maturing. AI powers intelligent incident response, detects anomalies before they become outage, maybe, and provides predictive analytics. AI analyzes logs, metrics, and trends at scale, finding patterns humans could miss. The ambition for the incoming years, maybe harness AI powers while managing its risk. Use AI to accelerate delivery and improve reliability, but do it responsibly, securely, and in compliance with regulation. It's a powerful tool, but it still requires the culture, measurement, and sharing principle we started with today. Let's now address the critical shift we are actually seeing. Multi-cloud is no longer optional. I think it's one of the challenges in the incoming year. It's no strategic. Some organizations are embracing multi-cloud for three compelling reasons. First, avoiding vendor locking. In fact, by architecting application to run across AWS, Azure, GCP, or even on-premise environments, you maintain leverage and flexibility to switch between this one, or just to build infrastructure on multiple cloud providers. You're not on a stage to a single provider. It could be pricing changes, service limitation, or maybe regional availability. Secondly, regulatory compliance and data sovereignty. With European regulation like GDPR, EU Data Act, and country-specific data residency requirements, you need control over where your data lives and how it's processed. Multi-cloud strategy lets you keep European customer data in European data center and comply with local regulation. Third, and maybe increasingly critical, geopolitical risk and political instability. We are seeing some trade tensions, regulatory conflicts between nations, and that can impact cloud service availability. If the government, without naming it, restrict access to certain cloud provider, your multi-cloud or hybrid architecture could provide business continuity. But it's a deal. Multi-cloud comes with complexity. You need portable infrastructure as code with IAC and Terraform, container orchestration, regardless of the underlying cloud technology, mainly Kubernetes driven, and maybe the hardest part, unified networking and security across hybrid environments, which can be a real challenge to deal with. Cloud providers are actually collaborating to simplify those parts. AWS and Google Cloud just announced jointly engineering multi-cloud networking solution, and that proves that multi-cloud is maybe becoming the next industry standard for DevOps. Multi-cloud and hybrid infrastructure done well give you resilience, compliance, and geopolitical independence. Multi-cloud done poorly just multiply your operational burden.
Okay, and lastly, the platform engineering and self-service and APIization. Not sure it's a word, but you get the idea. As systems grow more complex, expecting every developer to master cloud security, networking, operation, etc. becomes weirder. Platform engineering is the way to address this using self-service developer platforms. The idea is to treat infrastructure as an API using tools like Terraform with like module, cross-plane. You can expose reusable and standardized building blocks, not through infrastructure. Developer can interact with platform through Git API or things like Backstage from Spotify. And you can follow golden path, which embeds security, compliance, reliability, and cost control directly by design. GitOps tool like Argo CD ensure everything is version traceable and auditable, with policy engine or FinOps tooling enforcing guardrails automatically. Nowadays, the most successful teams are not the one adding more tools, in fact, but they are the one turning complexity into simple, secure, and self-service platform.
Thank you, everybody.